Welcome again to Virtual Science for the 2021 school year. This is just a quick review of the scientific method. Okay, we state a problem in the form of a question. We research your problem. You can either refer to outside sources of information or new information. We develop a hypothesis or an educated best guess to determine a possible explanation. We actually go ahead and do the experiment. We get results. We make conclusions, and then if necessary, we retest and change the hypothesis. Okay. Today's main focus is going to be on how to make a line graph, and this is on page 8 and 9 of your notes, so you should be opened up to that. It'll be real helpful if you get in the habit of looking at the lesson plan for the week, and having the right section of the notes open before you get started with the video. Okay. The first thing we need to do to make a line graph is identify the independent variable in the experiment. This is what we're going to plot on the x-axis. This is our independent variable. So it's going to go down here on the x-axis. This is the same thing as you do in algebra or pre-algebra. And then the dependent variable would be on the y-axis. Okay? So the y-axis is going to be the dependent variable. X-axis is the independent variable. Make sure when you label the axes, you include units. Make sure you include the independent variable. The range of the graph is what you determine next. Okay? And we're going to talk a little bit about that in more detail on the next slide. Okay. You're going to find the best way to label each line. So, if you need to decide if you're going to count by ones or if you're going to count by fives, how are you going to get everything to fit on the graph? Now, it's real important that we space the information out as much as possible. We don't want to have the graph all crammed up in one little corner. Each line or each marker on the graph has to increase by the same number. So you can't count by twos and then all of a sudden switch and say, well, it's not all going to fit, so I'll count by fives and then I'll count by tens. The best way to determine that is to look at our data and find what number you can count by. All of your data numbers have to fit on the graph, so we can't leave some of the big numbers out. Like I said, you're going to try and spread out the data as much as possible. You don't want it crammed up in the corner of the graph. Later in the year, we're going to do a PBA on this, and one of the things you'll be graded on is whether or not you used up most of the graph paper. Then after you plot all the points, you're going to draw the line of best fit through the dots. You're going to title the graph, and the easiest thing is usually just to say the independent variable versus the dependent variable. So we're going to take a look at an example of how exactly you would do all of this. Okay, so here we have practice. You got this blank graph paper here. You got some data points. Nothing is labeled. So the first thing you're going to do is on the x-axis, the IV, we can change the number of dogs. So when you look at this, okay, which one depends on which? And which one do we have control over? Well, we have control over the number of dogs that are going to eat. We don't have control over how much they're going to eat. So, but we're thinking the amount of food that gets eaten might depend on how many dogs we feed. So on the y-axis, the DV, we think the amount of food consumed is dependent on the number of dogs, which makes sense. The more dogs, the more food they might eat. So the amount of food consumed might depend on how many dogs there are. So we're going to put the amount of food consumed, the dependent variable, and we included the units, and that's real important. We included the units on the y-axis. On the x-axis, we're going to put the number of dogs. Now, since it's just a count, there's not really a unit. We don't measure dogs like in meters or something or kilometers. Here, we're measuring the amount of food in kilograms. Okay. And The next thing we need to do is figure out the range of the data for the x-axis, because we want to spread it out here. We don't want to just go 2, 4, 6, 8. Well, all 7 dogs will fit down in this corner, but we're only using the little small section of the graph. So we're going to look, and we're going to see that the number of dogs goes from 1 to 7. We can figure this out. Now this one's easy, but if we have some complicated data, we can figure this out by the highest number minus 0. So the highest number is 7 minus 0. That means there's 7 dogs that we need to fit on this graph. Okay, so we have 10 boxes. And if we take 7 dogs divided by 10 boxes, that means each box, if we use them all, we could count by 0.7. Okay, we don't want to count by 0.7. So we're going to round up to the next number that makes sense. Well, the next number up from 0.7 is 1. So we're going to count by 1. 0, 1, 2, 3, 4, 5, 6, 7 dogs. Okay, now we need to figure out how to number the y-axis. Well, we do it the same way. We take the biggest number minus 0, which is 50 kilograms. There's 50 kilograms that we need to spread out over our 10 boxes. Well, 50 divided by 10 is 5. 5 is an easy number to count by. It's not like 0.7. So we're going to stick with 5. We're going to count by 5. So we're going to go 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Now we've used up as much of the graph paper as it makes sense. Okay, now we need to plot the points on the graph. Our first point says 1 dog consumed 10 kilograms of food. So we're going to come here, 1 dog, and then 10 kilograms of food, and we're going to put our dot right there. We're going to find 2 dogs, which would be right along this line. It says 15 pounds, or 15 kilograms. So we're going to come over here. We should put our dot right there. The next one says 3 dogs, 25 kilograms. So we're going to come up 3 dogs along here. We're going to find 25 kilograms, and we should be able to put our dot right there. The next point says 4 dogs and 33 kilograms. We're going to come up from 4 dogs, and here's 31, 32, 33. So we're going to come over, and our dot should go right there. And the next one says 5 dogs and 38 kilograms. Well, again, we do that the same way. It's kind of like a road intersection. We go down Highway 5, and we come up to where Street 38 is. 1, 2, 35, 36, 37, 38. So we're going to go over, and right there at that intersection should be where we put the dot. And then we have 6 dogs and 47 kilograms. So this is the line for 6 dogs. This is 45, 46, 47. We put the dot right there at the intersection. And then lastly, we have 7 dogs consume 50 kilograms. Now we don't really want to just connect the dots. This looks like pretty much it's what's called a linear relationship. Okay? And we could have some experimental human error depending on when we measured the food. So we find the line of best fit. The line of best fit usually goes through most of the dots. In this case, I have 1, 2 that are slightly above, and I have 1, 2 that are slightly below, and it goes through most of the dots. Okay, so we could say, now we could predict that if we had even, we could extend this line, we could make a prediction of how much food 8 dogs would consume. Lastly, we need to give the graph a title. And remember I said it's really easy just to say IV, which is the number of dogs, versus the DV. So we could just say the number of dogs versus the amount of food consumed.